Good morning, everyone. It is a dreary, wet day here at my house, and so I decided that I was going to pep things up a little bit by putting on my ears because I wanted to think about a happy place. And when I'm talking to kids, it always makes me happy. So I hope you brought your thinking cap today because I have a challenge problem for you. Are you ready? I want you to think about the equation 23 times or groups of 15. So if you were given this problem, what is one way, one strategy that you might use to solve this problem? To tell you, I don't know 23 times 15 in my head. I have to use a strategy. Now, you're probably pretty flexible about thinking about numbers. You are a big fourth grader after all. So let's maybe look at one strategy that you see used often in your classroom. I know I see kids all the time at Osage Creek use the strategy of partial products. They think about the properties of mathematics that they can use to think about a flexible way to solve and manipulate these numbers. So let's kind of look at this program that I have. This website is called didax.com. It's they make things for teachers, but one of the cool things that they have is they have a virtual manipulative part of their website. So you can go on there and you can see all of these different tools that you can use since you're not as cool to actually use the tools, but you might have some other tools that you could use at home. So before we even start solving 23 times 15, let's talk about these blocks and what you think they might represent. Do these look like some tools that you have in your classroom? Yeah, you're right. So this smallest block is going to represent our ones. The longer block, you're right, is going to represent our groups of 10. And then the big squares, yes, 100s. So I don't think the colors make any difference, but as you're playing with this tool, you might figure out something you want to do with the colors. Today, when we're working together, I'm just going to ignore the colors, but I am going to think about the smallest block being a 1, the long rod being a group of 10, and then the bigger square being a group of 100, okay? So when you are solving this, I'm going to go ahead and disappear for now, but I'll see you at the end, okay? When you are solving this, because I know you are flexible, you are probably thinking about the distributive property of mathematics. So we know that the number 23 is really 20 and 3 more. And the number 15 is really a group of 10 and 5 more. Okay. So when we are multiplying those two groups of numbers, some strategies that I see kids use all the time is that partial products, like I said earlier. So they think about representing each factor in a decomposed way. So they would, let me grab my pointer, they would think about 23 as being 2 groups of 10 to make it their 20 and 3 more. So 1, 2, and 3. Same thing with their second factor, their 15. They would think about 15 as being a group of 10 and 5 extras. So 1, 2, 3, 4, and 5. Okay. So now when we are thinking about how can I use what I know about 20 plus 3, and 10 plus 5. What would you do first? Okay, so do we know what 20 groups of 10 is? We do, don't we? We know 10 groups of 10. That's automatic in our brains. 10 groups of 10 makes 100. So if I have 20 groups of 10, that's double 10 groups of 10. So it must be double 100. It must be 200. Nice. Okay, so there's my 100 and my 100. Now, what do we do next? Okay, so now we need to think about, I don't just have 10 groups of 20, I have 10 groups of 23. So what is 10 groups of 3? 10 groups of 3, 10, 20, 30. Now, if 10 groups of 3 isn't as automatic for you, you might be thinking about how you can use that commutative property of multiplication. How I know that I can change places with my factors and get the same product. So if I don't want to think about 10 groups of 3, I can use my commutative property and think about 3 groups of 10. They both have the same product. Okay, nice. Okay, so are we finished yet? Have we done everything we need to do? No, we've only dealt with 10 groups of 20 or 20 groups of 10 and 10 groups of 3 or 3 groups of 10. We still have 5, our factor 5 that came from our 15. We need 5 groups of 20 or 20 groups of 5. What would 5 groups of 20 be? If I didn't know, could I skip count and figure that out? Shall we do it together? Count with me. 20, 40, 60, 80, 100. Nice. So we need another group of 100. 5 groups of 20 gives me another group of 100. Nice. Okay. So now we've got 5 groups of 3. Is that a product you know fast? 5 groups of 3? Yes. 5 groups of 3 is 15. Nice job. So now after we get our 15 shown here, what are we going to do next? Are we finished? Do we know the product of our original equation? 23 times 15. We know parts of our product. We know that 10 groups of 20 is 200. We know that 10 groups of 3 is 30. We know that 5 groups of 20 is 100. And we know that 5 groups of 3 is 15. But now we need to take all of that and we need to put it back together because we started by breaking it apart by using that distributive property. So let's put it back together. You ready? So we have 200 and another 100. So that would give us a total of 300. We have 30. Shall we count on? 300, 310, 320, 330, 340, 341, 342, 343, 344, 345. So our product for 23 times 15 is 345. Nice. You guys did a really nice job thinking through that with me. So let's try one on your own. I think you're ready. Let's clear our board I just learned something new. I can just do that and it clears the whole thing. It's so cool. And I'm going to also get rid of all of the blocks and start us again. So what if I asked you to think about 31 groups of 12? Oh, Miss Kate's handwriting on here, not so good. I'm learning how to make it better. So 31 groups of 12. You can go online. Remember, didax.com. It's up here in the top. And search virtual manipulatives on their website if you want to use this tool to help you. If you don't want to use this tool, I am so okay with that. Let me come back on the screen so I can see you. I'm so okay if you don't want to use the tool. Draw a picture, use a piece of paper, use another strategy. This is just one strategy that I know I can use in my brain when I don't have a piece of paper or when I don't have tools. I can always think about breaking these numbers up, using that decomposition of numbers, using that distributive property to make numbers work in a way that helps me to think in my brain. So I want you to use a strategy that works for you. That's my strategy. It doesn't have to be your strategy, okay? The most important thing, though, is that we know what we're doing, we can explain what we're doing, and in the end, we have an answer that makes sense and is reasonable. So if you're doing all those things, you are on the right track. Okay, so turn in whatever it is that you show that you come up with to share with your teacher because he or she will want to see your good thinking. Okay, talk to you later. Bye.